Hello everyone, welcome to the Unacademy. Am I audible? Please respond. Am I audible or not? All of you. Please tell me so that I can start the session. Okay, fine. Let's crack GATE ESE with India's largest online learning platform. Get the subscription now and start your preparation with unlimited live and the recorded video lectures by India's top educators. So myself Ajay Das, I am MTech in computer science. I have a 8 plus year of teaching experience. Till now I have trained almost 20,000 plus engineering students for the GATE and training and placement. I have qualified the GATE exam 5 times below the AIR 500 and work as a freelancer in the many reputed institutes of India. So I have also qualified the Chhattisgarh State Electricity Board exam with the AIR 8. So download the Unacademy learning app and start your preparation sitting anywhere, anytime. What you will get? This is the major question that always arises in the mind of everyone. So the first thing, once you will get the subscriptions, the first thing you are going to have a daily live classes. Okay, and the second thing is structured courses. What is the meaning of structured courses? That your every subject has been planned and just after the completion of one subject you can start your another subject. The second advantage is for a single subject you can have a multiple educators. What is the advantage of this? Suppose if any one of the concept you are not able to grasp by the one educator, what you can do, you can switch to the another educator and you can start your preparation. The third advantage is the mod of the language inside the Unacademy platform is in Hindi as well as in English. So if some of the student is not comfortable in the language of Hindi, they can go to the another educator who are just teaching you in English. So means anyhow you are not you don't have to look upon any other online platform. So the third advantage is the live test and quizzes, and the last one is the unlimited access. You can access the lectures again and again until you get the entire concept. So this is the weapon of the Unacademy. Of course any organization come to the top whenever they are hiring the top educators. So in Unacademy almost every top educators are associated not in the sector of the GATE and ESE. If you will choose any one of the another sectors, you will find the same. So these are the educators from the background of the electrical, electronics and civil, and similarly from the mechanical and electrical. So of course this particular platform is the GATE ESE Quest. What is the meaning of Quest? Making the simple to solve the numerical, means how to solve the numerical in a as easiest way. So my dear friends, under the GATE ESE courses there are various branches. So according to your branch you can opt any one of the courses. These are the like branches which is given, like electronics, civil, okay, mathematics, instrumentation, CSIT. So these are the branches which Unacademy is offering you under the GATE and ESE. You can take or you can suggest your friends to get the subscription. But if you want to take the subscription, never forget to use this code, that is the IFA. You will get minimum 10% discount. How much? Minimum 10% discount. For any query you can personally send me the message on the Telegram, that is the 9264954515 for any kind of clarification. Okay, so the month wise subscription is given over here: 1 month, 3 months, 6 months. And my advice is, if you are looking for the GATE 2021, so of course the time is very less, but after the GATE exam, because whatever your performance will be in the GATE exam, it doesn't means this is your last attempt. After that there are more many exam which is waiting for you, like the ISRO, BAC, DRDO, TIFR, state government exam. Are you getting my point? So you can go for the another exam also. So in that situation, that's why I'm advising you go for the at least 12-month courses. And if you will compare the fee structure, then like just compare the fee structure with respect to the 6 month. There is a difference of only 5,000. How much? Only 5,000. So due to the 5,000, why you have to take the subscription for the 6 month? So must go for the subscription of the 12 month. And once you will apply my code, that is the IFA, you will immediately get minimum 10% discount, and your final fees will become 22,500. My dear friends, this is the most affordable fees which any student from any background can easily afford. Are you getting my point? So if you are looking for the GATE 2022, means if you are in a second year or the third year, or if you think that you require a lot of time according to your capability, you can go for the 24-month subscription. So once you will compare the subscription model with 12 months, there is a difference of only 5,000. My dear friends, logically, if you will try to think, then by the 5,000 you are getting a subscription of the 12 month more. 5,000 में आपको 12 महीने का सब्सक्रिप्शन मिल रहा है, अगर आप इसको लॉजिकली थिंक करने का कोशिश करोगे, ठीक है ना? अगेन, if you will use this code, that is the IFA over here, immediately you will get the minimum 10% discount and your final fees will become 27,000. इतने नॉमिनल फीस में 24 मंथ्स के लिए आपको दुनिया का कोई भी इंस्टीट्यूट, इधर इट इज ऑनलाइन और ऑफलाइन, नो वन कैन ट्रेन यू with the best educator and with the best planning of the test series and quizzes. Okay, so before ending this introductory session, I would like to say you one more thing, that never think that this particular promo code which is the IFA written over here, this is only valid for the GATE and ESE. This is not like that. Okay, any of your friends who are looking for the CAT, GRE, UPSC, banking, CGL, or any one of your family members are looking for the IIT JEE or NEET, all of them can use this particular code, that is the IFA. Please note it down. All of them can use the code IFA and all of them will get the subscription. So whatever the courses, almost 45 plus courses are available in the Unacademy platform. Whatever the courses, anyone in your known circle wants to get the subscriptions, all of them can use the code IFA and they will get the minimum 10% discount. So this is the introductory session. Now let's come to the subject for which you people are waiting for. So let's crack GATE at the rate first attempt. This is our slogan. Let's crack it. So why this is our slogan is given as, because we believe if the teaching process is a magical process, if the teaching process will be in such a way, and if you will put your some of the dedication, then we can assure you you can crack the GATE exam in the first attempt. So of course this is the mutual effort. So we can give you just a logic how to solve the numericals, we can give you the concept, we can give you the logic, we can give you the approach how to solve the numerical, we can give you the strategy, we can put the rankers in front of you which who can tell you what is their planning in their preparation time. So combining all those things, if you will follow each and every steps, then you can crack the GATE at the rate of first attempt with better rank, whichever you bring. Okay, so let's come to the subject, that is the computational theory, or you can say the theory of computation, TOC in short form. And the topic is the grammar. Already in the last lectures, means in the yesterday lectures, I have told you this is the series of the grammar. Okay, I have collected the three different series, grammar 1, 2 and 3. So this is the second part, and from this particular section, every year in your GATE exam, almost 2 to 3 questions were asked. Means if you will talk about the marks weightage, there is a weightage of 4 to 5 marks. So my dear friends, now you can imagine what is the importance of this particular topic inside the theory of computation. So let's start the subject. As yesterday we have already discussed about the basic introduction of the grammar. Now what I am doing, I'm giving you a question. Suppose the language is given a to the power n, b to the power m, where n is greater than, and what you have to do, you have to write a grammar. Write grammar for, what will be your thinking approach? दिस इज द मेजर क्वेश्चन। आपका थॉट प्रोसेस क्या होना चाहिए इस पर्टिकुलर लैंग्वेज के लिए? अगर आपको ग्रामर लिखने के लिए बोला जाए तो आपका थॉट प्रोसेस क्या होना चाहिए? देखिए, अल्टीमेटली वंस यू विल इंप्रूव योर थॉट प्रोसेस, then in the time of exam you never need to pick the pen. Looking upon the question you can directly answer the question. आपको पेन उठाने की भी जरूरत नहीं पड़ेगी, लेकिन उसके लिए आपको धीरे धीरे अपने थॉट प्रोसेस को बिल्डअप करना पड़ेगा। क्या करना पड़ेगा? बिल्डअप करना पड़ेगा। सो माय डियर फ्रेंड्स, प्लीज ट्राई टू अंडरस्टैंड दिस क्वेश्चन. The question is given as n is equal to a to the power n b to the power m, where n is greater than m. Means the counting of a, that is the number of a, should be greater than number of. This is the question which is asking. Means what kind of string the language will contain? The language will contain, like, if it can contain the a, because a means a to the power 1 b to the power 0. So here 1 is greater than 0, so this condition is satisfying. N is greater than m. Again you can consider a to the power 2 and b. Similarly you can consider a to the power 2, a to the power 3 and b, a to the power 4 and b, a to the power 4 and b square. So in all the situation, the value of n is greater than m. The value of n is greater than. Are you getting my point? So all these strings will be belongs to this language. But if someone is saying the string a b, so this is not possible, because the counting of a can never be equivalent to the counting of b. So how to write the grammar? My dear friends, please try to analyze one thing. To write a grammar, what will be the logic? I'm just writing a logic first of all, and then I will write the grammar. See over here. Suppose first of all we are generating the equal counting of a and b. Means we are generating equal counting of a and b, that is the a to the power n, b to the power n, where n is greater than equal to 0. So this is the language which is containing equal counting of a and b. Now what I am doing, I am concatenating the another language with this. This is the a to the power m, where m is greater than equal to 1. Where m is greater than equal to 1. So my dear friends, please try to understand this particular two languages. What I have written the two different languages. This is the language L1 and this is the language L2. Here we are generating the equal counting of a and b, and we have concatenated the counting of a from the left hand side. So, and the value of a over here is greater than equal to 1. What does it mean? So once you will concatenate the a from the left hand side, the counting of a will become greater than the counting of b. Yes or no? The counting of a will become the greater than the counting of b once you will concatenate this from the left hand side. All of you, are you getting my voice? Please respond me. क्योंकि देखिए, जब तक आप लाइफ में बोलना नहीं सीखोगे ना, तब तक आप लाइफ में कोई चीज अचीव नहीं कर पाओगे। क्योंकि आप समझ रहे हो कि अगर हम लोग कभी भी बोलते नहीं है तो वो कॉन्फिडेंस नहीं आ पाता है। सो ऑलवेज स्पीक आउट, वॉट एवर यू आर थिंकिंग, प्लीज स्पीक आउट। ओके, सो देखिए, वॉइस अगर लाउड होता है तो कॉन्फिडेंस भी हाई होता है, तो हमेशा बोलना सीखो। सी ओवर हियर. So once you are concatenating the counting of a from the left hand side, definitely the counting of a will become greater than the counting of b. So what you can write after the concatenation, a to the power m plus n and b to the power n, where m is greater than equal to 1 and n is greater than equal to 0. So if you will take the value of m is equal to 1 and n is equal to 0, what string will be generated? A to the power 1 plus 0 and b to the power 0. So ultimately it will become single a dot epsilon, so it will become a. So here the counting of a is greater than the counting of b. This is correct. This is the lower value we are considering. So of course, ultimately what you can write? You can write a to the power I, b to the power j, where I is greater than j. means this particular language actually a combination of two different languages. This particular language actually a combination of two different languages, that is the L1 and L2 in a concatenated form. So now you can get the logic. So ultimately L is equal to a to the power n b to the power m, where n is greater than m, is the combination of two different languages, that is the a to the power n, where n is greater than equal to 1, union not union, okay, concatenated with a to the power m b to the power m, where m is greater than equal to 0. You can take nm, not a problem at all. Suppose this is the language L1 and this is the language L2. So how to write the grammar? See over here. From the S we are developing A, B. See, from the this can be generated by the non-terminal A and this can be generated by the non-terminal B, and both the non-terminal are appearing in a concatenated form. So A and B are appearing in a concatenated form. Now from the A we will generate, from the non-terminal A we will generate the L1, and from the non-terminal B we will generate the L2. So just write down over here how you will generate this particular language. You can generate easily AA slash, yes or no, and from the B you have to generate this particular language, equal counting of A and B. How you will write the grammar? A B B slash silent. So finally this will become the final grammar of your given question. This will become the final grammar of your given question, and this will become the right answer. Similarly, my dear friends, if I am just switching the questions, if I am just making a little bit difference, L is equal to a to the power n b to the power m, where n is greater than equal to, so this is the combination of a to the power n. Now this boundary condition will become greater than equal to 0 dot a to the power m b to the power m, where m is again greater than equal to 0. So this is saying, this particular condition is saying that the counting of A may be equal to 0 or the counting of A will be greater than 0. So in that sense, what you have to do, you have to make a little bit change in this production rule only. So what will be that change? The grammar G would be written as S2 AB and A2 AA slash epsilon and B2 ABB slash epsilon. So this will become a final. Got it, everyone? This will become the final grammar. Now again I am making a little bit change and creating a question of the GATE 2007. So this time I am giving you a numerical from the GATE 2007. See over here. The language is given in this form. L is equal to a to the power I b to the power j, where I is not equal to j, and they are asking find G, find the grammar G. Means the 4 options were given and you have to find out the correct grammar G. Got it? So first of all we will try to find out what will be the logic. See over here, what will be the final logic? Okay, so just look upon here, so L is equal to, we can write, see, I is not equal to j. What does it mean? If I is not equal to j means if The I can be greater than J or J can be greater than I, but they can never be equal. Are you getting my point? So here it will become A to the power I, B to the power J. Either I is greater than J or means union, or you can write A to the power I, B to the power J, and J is greater than. Are you getting my point or not, all of you? So if I is not equal to J, means there are three different conditions. Either the I is greater than J or J is greater than I. But this condition will never hold. This is the A to the power I, B to the power J, where I is equal to J. This condition will never hold because it is saying I is not equal to J. So according to this, we are having a two different condition. This is the first condition and this one is the second condition, and these are coming in the form of OR. What is the meaning of this? The meaning of this is the union symbol, and the meaning of this is, are you getting my point? The meaning of this is OR. Now I have told you how to write the grammar for this language. Suppose this is the language L1 and this is the language L2. So if this is the language L1 and L2, you know individually how to write the grammar for the language L1 as well as L2. Now you just combine them and you will get the answer. So let's see how to write the grammar. See, from the S we can derive AC or CB. See over here, what is our ultimate objective? Our ultimate objective is the C will generate A to the power N, B to the power N, where N is greater than equal to 0. Okay, and from the A, what we will generate? We will generate A to the power N, where N is greater than equal to 1, and we have concatenated these two. So whenever the counting of A will be concatenated from the left hand side, okay, the counting of A will increase with respect to the counting of B, and by the non-terminal B, what we will do? We will generate the counting of B. So B to the power N, where N is greater than equal to 1. Now here C and B are in concatenated form. C is generating equal counting of A and B, and whenever you are concatenating the counting of B from the right hand side, it will increase the value of B with respect to the A, and ultimately our both the objective, this is the objective 1 and objective 2 will be fulfilled. And this is this symbol which is I am written over here, this is the OR symbol. Means either you can choose the production number 1 or you can choose the production number. Got it, everyone? So applying the same method, you have to write each and everything. So from the non-terminal A, we will generate AA/A. From the non-terminal B, we will generate the BB/B. And from the non-terminal C, we will create the equal counting of A and B. So ACB/Z. So this will become the final grammar G. And this will become the answer. So this kind of grammar is called context-free grammar. This kind of grammar is called context-free. So my dear friends, if for any language there exists a context-free grammar, this is the language L which is given over here, and for the language L we can write a context-free grammar. So if for any language there exists a context-free grammar, what does it mean? The language is context-free. Means this particular language is context-free language, and every context-free language can be solved by the PD. Now let's see, I'm giving you another question of the GATE 2010. Okay, four different languages are given. Annual L1 is equal to a to the power n, b to the power n, where n is greater than equal to 0. L2 is given as a to the power n, b to the power m, where n is not equal to. L3 is given a to the power n, b to the power 2m, where n is not equal to. Okay. And L4 is given as a to the power n, b to the power n, and c to the power, where nm is equal to greater than equal to 0. And question is, which of the following are context free language? Text free. So my dear friends, if the language is context free, if you are able to write the context free grammar, or you are able to make a PDA. See, when in which situation you will claim the language is CFL. CFL means context free language. In which situation we are able to claim whether the language is CFL or not? There are two different situations. Okay, if we are able to design a PDA, if there exists a machine PDA for the given language, then the language will be called a context free. Or we are able to write CFG. CFG means context free grammar. If any one of the things you are able to do, you can easily claim the given language is a context free language. So my dear friends, for the first language we can easily write a grammar, that is the S2 ASB slash epsilon. So this is the context free language. Again, this will become a context free. Already we have seen that in the previous example. And again, of course, for this language also we can write the context free grammar, because what we have to do, the counting of A, the counting of B is just a twice of the counting of A. So again we can write the context free grammar. Now let's see the language L4. In the language L4, what it is given? It is given as a to the power n, b to the power n, and c to the power m, where nm is greater than equal to 0. Now let's try to find out what is the logic of writing a context free grammar. See my dear friends, here the counting of A is equal to the counting of B, and the counting of C is independent. So how to write what is the logic of writing the grammar over here? So suppose this is generating by the non-terminal A and this is generating by the non-terminal B, and we have to concatenate both the languages. So how we will write the grammar? From the S we will derive AB. S is the start symbol of the grammar. Now from the non-terminal A we will produce the equal counting of A and B. So we can write AAB slash epsilon. Why we are taking the epsilon? Because the boundary condition of n is given as greater than equal to 0. Similarly, from the B we will generate any counting of C. So we can write CB slash epsilon. So this one will become the final grammar. So this is the context free grammar. Of course, by designing a PDA you can also check the same thing, not an issue at all. By designing a PDA we can also check the same thing, whether the language is context free or not. So in this manner we can easily say this particular language is a context free. So there was an option which is given as all. So all of above will be a context free language. So in this manner you can easily find out the answer. Now let's see the another question. Let's try to see the another question. See over here. Okay. Now I'm just increasing the difficulties level of the problem. See, this is the very one of the nice problem related with the languages and grammar. See, the languages is given as n is equal to a to the power n, b to the power m, and c to the power k, where k is equal to mod of n minus, and what you have to do, you have to write a grammar, write a, my dear friends, from this particular question you will learn a lot of things, so please try to understand the solution of this problem. Okay, so just try to understand the solution of the problem. See here, what is the condition is given, the k is equal to n minus m. It is indicating there are three different cases. The case 1, of course three different cases will arise if the counting of n is equal to m. This is the one cases, and second one is means the first cases can be n is equal to m, or n greater than m, or n is less than m. So we can have a three different situation, and in all the situation the value of k will be vary. The value of k will be vary because the value of k is depending upon the counting of n and m. So I am taking the first case where if n is equal to m, then k is equal to 0, and in that situation language L1 will become a to the power n, b to the power n, where n is greater than equal to 0. Got it? Similarly, I'm just considering the case 2. So if n is greater than m, then in that situation k will become n minus m, and this implies n is equal to k plus m, and the language will be L2. So, and what will be the L2? L2 is equal to a to the power n. A to the power n is given over here, and what is the value of n over here? This is the k plus m, and this one is the b to the power m and c to the power k. Fine. Now let's take the case 3. In the case 3 we are assuming if the n is less than m, then the k will become m minus n, and this implies m is equal to k plus. So finally it will generate a language L3. So L3 will become a to the power n and b to the power k plus n and c to the power k. Okay, c to the power k. Just write it in an arrange form. How we can write? We can write a to the power n, b to the power n. Yes or no? If there is a plus symbol, we can separate it. So a to the power n, b to the power n, again b to the power k and c to the power k. Yes or no? Similarly, we can do the same thing over here. If a to the power k plus m is given, we can write a to the power k, again a to the power m, b to the power m, and c to the power k. Now, individually, if you are able to write a context-free grammar, then we can write the context-free grammar for the language L. Means here what we are observing, the language L is nothing but the combination of three different languages. That is the language L1 union L2 union 3. Are you getting my point or not? The language L is the combination of three different languages. That is the language L1 union L2 union L3. So what you have to do, you have to write a grammar. Suppose the language L1 is generating by the non-terminal S1. What is the meaning of union OR? So just give this kind of symbol over here. And language L2 is generating the non-terminal S2, or language L3 is generating by the non-terminal S3, and this language is generating by the non-terminal S. So S will derive this. So S will derive this. So how we will write the grammar? The non-terminal S, which is with respect to the L, okay, it will derive either S1 or S2 or S3, and from the non-terminal S1 we will derive the language L1, from the non-terminal S2 we will derive the language L2, and from the non-terminal S3 we will derive the language L3. Now let's see how to derive each and every languages. So my dear friends, looking upon here, you easily understand how to derive this particular language. This will be derived by the S1 derives A S1 B slash epsilon. Yes or no? This is the very simple. We can write over here. Now let's see how to find out the grammar for this. See, you have to only find out the logic. Okay, what the L2 is given? L2 is given as A to the power K, again A to the power M, B to the power M, and C to the power K, where Mk is greater than equal to 0. So looking upon this particular language, what we are identifying, the counting of A and B are equal and the counting of A and C are equal. So we have to maintain the counting by writing a grammar, and the language L2 we are deriving by the non-terminal S2. So we will start from the S2. So see over here, from the S2 what we will do, first of all we will produce the equal counting of A and C. First of all we will produce the equal counting of A and C. So how we will write? We will write A, S2 and C. This is the recursive call, and by calling recursively we can generate the equal counting of A and C. Yes or no, all of you? By calling S2 recursively we can generate the equal counting of A and C. Now after generating the equal counting of A and C, we will reduce the S2 by the another symbol. Suppose this is the A. Okay, we will reduce the S2 by A. Now from the A we will generate this, and from the S1 or S2 we are generating the this. Are you getting my point? So from the S2 we are generating the this, and ultimately the S2 will be reduced by A, and this A will generate the equal counting of A and B. So how you will generate the equal counting of A and B? So A2 A B slash. Got it? So this will become the final grammar for the above language. This is the language 2. Let's see the language 3. Let's see the language 3. What the language L3 is given? The language L3 is given as in this form. So this is nothing but A to the power n, B to the power n, and again B to the power k, and C to the power k, where nk is greater than equal to 0. Now this is very simple. This is very simple. See, here we are generating the equal counting of A and B. Suppose it can be generated by B, and this is generating equal counting of B and C. It can be generated by C. So ultimately from the non-terminal S3, we have considered with respect to the language L3, and S3 is deriving non-terminal BC. From the non-terminal B we will derive this kind of strings. So what we will do, and of course B and C will come in the concatenated form, so that's why we have concatenated this. So here what we can write, from the B we can generate the equal counting of A and B. So A B slash epsilon, and from the C we will generate the equal counting of B and C. How we will do that? B C and C slash epsilon. Got it? So finally the grammar will look like this. S derive S1, S2 and S3, and from the S1 this will be the first part, from the S1 this will be the first part, and from the S2 this one will become the second part, and from the S3 this one will become the, got it, and this will be the final answer. This will be the final. So I hope all of you got this particular point. And from the single question, you have learned a lot of things. How to write the grammar for the different languages. How to write the grammar for the different languages. And I'm just making a twist of this particular language. And I'm just asking you to write the grammar. See guys, this is the another questions which is given. Suppose the question is given as L is equal to a to the power n, b to the power m, c to the power m, and again c to the power n, suppose. And here it is given n is greater than equal to 1 and m is greater than equal to 0. What I have done, I have just changed the condition. In the earlier example, both were greater than equal to 0. But here I have just changed the situation. Here the n is greater than equal to 1 and m is greater than equal to 0. So what is the minimum string the language will contain? See, if m is equal to 0, it will contain AC. Yes or no? If both are 1, it will contain A, B, C, C. Okay. If both are 1, it will contain A, B, C, C. Means this is coming for the n is equal to 1. For the n is equal to 1 and m is equal to 0. This is coming for the n is equal to 1 and m is equal to 1. And the next thing could be what? A square, C square. This will be contained when the n is equal to 2 and m is equal to 0. So in this manner, whatever the possibilities are there. So for this kind of language, you have to write a grammar. So you have to make a little bit change inside this particular grammar. Means what it is saying, it should contain at least single A and single C, or more than single A and single C. Are you getting my point? But at least it will contain single A and single C in every string. This will must appear in every string. You can increase the counting of A and C. So how to write the grammar? See over here. From the S, we are deriving ASC. And by calling it recursively, by calling the non-terminal S recursively, we are generating any counting of A and C. But whenever we are reducing the non-terminal S by the another non-terminal, then suppose we are reducing the non-terminal S by the another non-terminal A, then A will never come alone. It will carry the A and C because it is given n is at least 1. So for that reason, you have to carry at least one A and one C. And now what you can do, you can reduce the A by this. Means by the A, you will generate this. This is generating by S and this is generating by A. So what you can write? A, C and slash side. So I have done a little bit changes over here. But we have carried the A and C, which I haven't done in the previous example. In this example, here the A is coming alone. Why? Because M and K both are greater than equal to 0. So accordingly, you can think, you have to improve yourself, you have to think about the question. Suppose I'm just making a little bit twist of the same in the same question. Suppose it is given as A to the power n, B to the power m, C to the power m, and again C to the power n. And here both are given as nm greater than equal to 1. Means what is the minimum string that could be generated? The minimum string will be A, B, C, C. And how to write the grammar? I hope you got the point. S2, ASC, and recursively it will generate any counting of A and C. But before moving to the another non-terminal, it will carry AC. And by the non-terminal A and by the recursively calling, we can generate these things So this will become BAC, and rather than reducing by the epsilon, we have to generate the BC. We have to reduce by the BC. So this will be the grammar for the above language. So in your exam, you have to be very much careful what the terminal condition is given. These are called the terminal condition. These are called the terminal condition. Okay, what the terminal condition is given, you have to be very much careful, because most of the time what happen, student, even though they know the answer, okay, and in the like in the process of solving the numericals, they are in very much hurry, and by partially looking upon the question, they immediately answer the options. Are you getting my point? Don't do that kind of mistake. Good evening, Adarsh Gupta. Okay, they do this kind of mistakes. So never be in hurry. Just look upon the terminal condition, and accordingly you have to write the grammar. Got it, everyone? Now I think the fundamental concept of the grammar is very much clear to all of you. Now, if it is clear, now let's move to the questions. So before moving to the questions, let's see one more example. One more example that is quite interesting. Okay, and this question were asked many time in the GATE. Many time in the GATE. L is equal to WC W reverse, where W belongs to AB full star and sigma is equal to A comma B comma C. See what the language is saying. W belongs to AB whole star means the W could be any combination of AB, and this is the set of input symbol will contain the A, B and C. Of course, the bit means mid symbol is the C. Now let's see. See, what is the minimum string that could be generated or that belongs to this language? That is the C. When W we are considering the epsilon. What is the next minimum string? ACA. When W is equal to, of course, taking means if W is equal to A, then what will be the W reverse? It will be a no changes, or it could be a BCB when W is equal to B. But if you are considering the W is equal to AB, so what is the string that will be generated? ABC, and here you have to write the W reverse. If W is equal to AB, then the W reverse will become BA. Here the W reverse, there will be no any changes. There will be no any changes. So it will become B and so on. You have to write a grammar in such a way it will generate this kind of string. So just pick the string and find out the logic. We are just considering these strings outside to find out the logic, how to write the grammar. See what strings we are considering. We are considering the string A, B, C, again B. Okay, here we have considered the W is equal to. So looking upon this string, what you are analyzing? See over here, the first and the last symbol are same. Similarly, these two symbols are same. Means this is nothing but palindrome. This is nothing but palindrome. And which kind of palindrome? Whatever the value of W you will consider, here W reverse will come. So if the length of W, if length of W is equal to odd, then this one will become even. Of course, W reverse, the mod of this value will become even. Or if the length of W is equal to even, then again W will become even. But in both the situation, this W combination will create the even. But there is a one more symbol in between them. So once you will add the one with even, it will become So ultimately it is a palindrome, no doubt in that. But this is the even length palindrome. This is generating an even length palindrome. Got it, everyone? So what will be the logic of writing a grammar? See over here, our grammar should be written in such a way that the first and the last symbol will be same. So the grammar will be look like this. S will derive ASA. Of course, recursively anytime whenever you will call this, it will generate the first and the last symbol as a same. Similarly, or what you can do, BSB. Again, either you will call this or you will call this. Always the first and the last symbol will remain same in every position. In every position. And at the last time, the mid symbol is always C. So the last time S will be reduced by C. So this will become a final grammar. This will become a final grammar G for the above. Now I hope you got my point. Now let's come to the numerical. So my dear friends, this is one of the numerical that were asked in your GATE exam in 2017. So first of all, let's try to read the question very carefully and then we will try to find out the answer. What is the question is given? Consider the context-free grammar over the alphabet A, B and C given below. S and T are the non-terminals. Of course, the grammar has been defined with the non-terminal, terminals, start symbol and production rules. Okay. So S and T are the non-terminal. Two different grammar is given. The grammar G1, grammar G2. And what the question is asking? The question is asking the language generated by grammar G1 intersection the language generated by grammar G2. Means you have to find out the common string that belongs to the language generated by grammar G1 and the language generated by the grammar G2. Got it? So first of all, let's try to find out what is the language generated by grammar G1. So just see the grammar G1. It is given as S2 ASB slash T and T2 CT slash Z. So just see over here. See, from the S, what we are doing, we are deriving the SASB. Again, reduce the S with the same, means recursively call the same production. This is the production number 1 and this is the production number 2. So recursively call the same production. It will generate A square S B square, and if you will call the n times, it will generate A to the power n S B to the power n. Now reduce the S by T. So it will become A to the power n T B to the power n. Now the T can be reduced by this particular production rule. This is the production rule 3 and this is the production rule 4. So once you will reduce the T first time, it will become A to the power n C T to the T B to the power n. So once you will reduce the T by m times, so it will become A to the power n C to the power m T, again B to the power m. Now reduce the T by epsilon. Just use this production T2 epsilon. So it will generate A to the power n C to the power m and again B to the power n, where nm is greater than equal to 0. So how to decide the boundary condition? This is the boundary condition, or you can say the terminal condition. So how to decide the boundary condition? That depends upon the minimum string the grammar is generating. The minimum string the grammar is generating. See upon here. From the S you can derive T and from the T you can derive epsilon. Means the grammar is generating the string epsilon. When the epsilon will be created? When the value of n and m both are 0. If you will consider the value of both is equal to 0, then it will generate a epsilon. Otherwise not. Otherwise not. So ultimately, this is the language generated by grammar G1. Similarly, looking upon the another grammar, you can easily identify here the counting of B and A are equal. So it will generate B to the power N, C to the power M, and again A to the power N, where Nm is greater than equal to 0. So my dear friends, please try to analyze. If I am thinking about this particular grammar, language generated by grammar G1, this is the A to the power N, C to the power M, and again B to the power N, where Nm is greater than equal to 0. What kind of string it will generate? What is the minimum string it will generate? Epsilon. What is the second minimum string it will generate? Single C. When the single C will be generated, when the value of N is equal to 0 and the value of M is equal to 1. Because both are given as greater than equal to 0. You can consider anything. So you can consider the N is equal to 0 and M is equal to 1. It will generate a single C. Similarly, it can generate a double C. Whenever you are considering the N is equal to 0, M is equal to 2. Similarly, it can generate the ACB when it will generate when the N is equal to 1 and M is equal to 1, and so on. So my dear friends, if similarly this will generate all the strings. So in both the languages, this kind of string can never be a common. This kind of string will never be a common. Means all the string which is containing A and B both, that can never becomes a common string. Why? Because in this situation, all the string is starting with A and ending with B. And in this situation, it is starting with B and ending with A. So what kind of string will get common? This kind of strings will get common. Epsilon, single C, double C, triple C, and so on. So finally, what we are analyzing from this problem, the language generated by grammar G1 intersection the language generated by grammar G2 is equal to C to the power N, where N is greater than equal to 0. And this language is a regular language. I hope you know about this. This language is a regular language. Why regular? Because we can make a DFA. A language is called regular if we can consider we can construct a DFA for the same language. How you will construct a DFA? Initial state will be a final state, and over the input symbol C there will be a self loop. So this is the machine M which is DFA in nature. Now let's try to solve the numerical. What the option is given? The first option is given as finite. This is not true because it will carry the infinite number of strings. The intersecting language will carry the infinite number of strings. And the second option is given as not finite. Not finite means infinite but regular. Of course, this is the correct state. Of course, the intersecting language will have a infinite number of strings and it is regular because it can be solved by the DFA. And the third option is given as context free but not regular. Of course, all the regular languages are context free. All the regular languages are context free. So this is the true statement. But saying not regular, this is the false statement. This is the false statement. So this will be never be a right answer. Recursive but not context free. My dear friends, if it is regular, then it will be a context free, because all the problem, all the languages that can be solved by the DFA can also be solved by the PDA, because PDA is the more powerful machine. I have already discussed in the previous lectures. Yes or no? So if you are saying a recursive, not a problem at all. Of course, if the problem can be solved by the DFA, it can be solved by the PDA, it can be solved by the Turing machine. So it will be a recursive. But saying the statement not context free, this is not true. Because we are able to solve the same language, intersecting language by the DFA, it can be solved by the PDA. So of course this statement is not true. Got it? So finally, what will be the right answer? The right answer will become B. Got it, everyone? So this is the approach to solve the numerical. Always try to think very carefully, read the question, just find out the more many question from the single questions and then go ahead. देखिए हमारे टाइम में भी हमारे गुरुजी लोग कहा करते थे कि इट इज बेटर टू सॉल्व one numerical 5 times rather than solving the 50 numericals in one day. क्योंकि अगर आप एक न्यूमेरिकल को एक दो बार तीन बार सॉल्व करते हैं ना तो वो न्यूमेरिकल के ब्रांचेस क्रिएट होना शुरू हो जाते हैं एंड बाय द डिफरेंट डिफरेंट ब्रांचेस यू विल हैव अ लॉट ऑफ थिंग्स. So that's all for today, guys. I have considered the more many questions. Again, I will tell you, if you want to get the subscription, this is my code. Never forget to use this particular code, okay, which is IFA, and you will get minimum 10% discount. Or in another situation, you can contact me like 9264954515. This is my Telegram number. You can personally contact me to have any kind of doubts or clarification. So before leaving this session, I will tell you this is my code IFA and must subscribe this channel. If you are learning a lot of things from this particular channel, never forget to subscribe this channel. Put your valuable comments so that the other student will get the inspiration, and press the bell icon button to get all the notification. Once you will press the bell icon button, whenever I will come online, you will get the notification so that none of your lectures will missed. So bye everyone, take care, good night. मस्त रहिए, मेहनत करिए, आगे बढ़िए, क्योंकि मेहनत करने वालों की कभी हार नहीं होती. बाय, गुड नाइट.